Hi, folks. We are going to be looking at 1.7 today. And 1.7 is about piecewise functions. Or piecewise defined functions. I've seen them called both. Your book calls them just piecewise functions, so we'll go with that title. And piecewise functions are, I guess, in their most basic sense, just a function. We're going to be graphing. I should mention that right off the bat. We're going to be doing a lot of graphs this section. That's pretty much all we're doing is graphing piecewise functions. And we're looking at different transformations, translations of some base functions, just like you've done parent functions in the past. What they're going to look like, what these piecewise functions as graphs look like, are essentially graphs that are composed of little pieces. That's where the word comes from. That's why we call it a piecewise function. Little pieces of linear equations. We take a section of a linear equation and combine it with another section from another linear equation and so on until we get the entire function. All right. So they are functions in the sense that they are they do pass the vertical line test. They're just going to be a little bit different. And you know one of these already. I know you do. You've done it before. And every year I do this, people start, as soon as I start with this one, they're like, oh yeah, we did do this one. But you didn't know it was a piecewise function. And let me just move this here over a little bit. Oh, we'll leave it right there. All right, so people didn't know they were a piecewise function. Oh, I just did it again. All right, and it's this function right here. You've already mastered this one, I'm sure. Maybe not. I'm going to start as if you didn't. So, y equals absolute value of x. What does that look like as a graph? Well, if you remember, and if we were to say make a table of values, what do we do with that? We know absolute value of x is the distance from 0. So if I have x's and I have y's, if I put in, say, -2, I get a y of, in other words, y equals the absolute value of -2, I get +2. If I put in -1, absolute value of -1 is 1. I put in 0, we get 0. 1, we get 1, and so on. You remember this one, right? You remember it always says it makes it positive. Well, what it's really doing is graphically, you're starting out at this point here, and then you're going up through 1, 1, 2, 2, 3, 3, and so on. And then at the other direction, you're going through -1, 1, -2, +2, -3, +3, and so on in this direction as well. And I pulled off my first graph in this app. Beautiful. So it'll look like that, right? You remember you always called it the V-shaped graph, right? That's what your teachers always told you. Remember, if you see absolute value, you think V-shaped graph. Well, you may not have realized, but this is a piecewise function. If we look at it in its most basic sense, and let's see, I need to go up here and get myself a little more room. It does not want to cooperate, so I'll just do that. All right, so if we look at this, as a piecewise function, what we're talking about when we're on this side of the graph, the negative side of the graph, what we're doing is we're graphing, let's see, there we go. We're graphing y equals the opposite of x, right? When it's over here, when x is less than 0, you could even say less than or equal to. And when it's on this side, we're graphing y equals x. So what we did is take a little piece, and I can say when x is greater than or equal to 0. What we're saying here is we have two separate linear graphs that we only took part of them. We took the part when x was greater than or equal to 0 and made it y equals x. We took the piece of y equals -x when x is greater than or less than 0. So we really do have a piecewise function here. You just didn't know it that way. So I want you to be aware, you already knew one. We're going to come back to this idea of using more than one function. But right now, let's just look at some more graphs of this one here. Let me get another page. Let's go over here. And let's look at another graph. Let's see how much you remember about this graph. Because if you remember this one, we can do just about anything we want today. We're only going to do a couple graphs today. We're going to do a couple more tomorrow. All right, today let's look at this one. If I said y equals 2 times the absolute value of x. Now think back, what happens to a graph when we have a normal function and we multiply outside the function? I always call it outside because it's outside the absolute value. It's the same as if you had said y equals 2 times x squared. What happened to that graph? That v got narrower. Remember that? All right, so it got narrower because what happened is it went, instead of going from, it still goes through 0, 0. Yes, if I put 0 in for x, I still get 0. So it hasn't moved anywhere. It hasn't moved up, down, left, or right, but it has gotten steeper. It's gotten narrower. And what we're going to talk about here is it's going to go, it used to go over 1, up 1. But now because of that multiplier 2, it's going to go over 1 and up 2. And in the same way, it used to go back 1 and up 1, but now it's going to go back 1 and up 2. So we end up with that graph that looks like this. And let's see if I can pull this off. There we go. And we have that graph. Remember this? All right. And if you think about it, what would happen if instead, let's use a different color, we'll just use the same one. And what if instead I said y equals 1/2 the absolute value of x? What happens to this graph? Well, think about it. If I have 1/2 times whatever the x was after it came out of the absolute value, it's still going to start at 0. But going over 1, well, the absolute value of 1 is 1 times 1/2 is 1/2. So at 2, it would be 1. At 4, it would be 2, and so on, right? And in the same way, if I go negative, if I put negative 1 in there, I put negative 1 in for x, I would have positive 1 times 1/2 would be a positive 1/2. 2 would be 1. And we'd get the same behavior over here. So what's happened to this graph? Well, same thing we saw with the other one. It's going to be going out this way, though, now. This direction and this direction. So what's happened? It's gotten wider, right? It widened out into this graph. So the 1/2 told me, I always think of it as kind of like the rise or run of these linear pieces. Instead of it having a slope of 2 when it was multiplied by 2 on the outside, it was multiplied by 1/2 on the outside, so it has a slope of 1/2. Over here, it has a slope of negative 1/2, right? Down 1 over 2. So this is what happens to that graph. So let's look at and see if we can figure out anything else. What if we did, whoops, let's do, I wanted that color. All right, let's do y equals negative, and let's get tricky, negative 3x. All right, now what happens? Well, we've got that 3 multiplying the x. So if I put 1 in, it automatically becomes 3. Absolute value of 3 is 3. And then we take the opposite of it. Remember what this negative does in front? It takes that graph that was going like this, and what does it do? It makes it go down like that, right? It flips it over. It reflects it across that x-axis in proper math terms. But we'll get to that stuff. We're not doing that yet. So right now, we're going to go over 1 and down 3. Right? Because at 1, we got 3 when we multiplied by a 3, and then we take the opposite of that absolute value. So what happens at negative 1? Well, negative 1, again, is going to be multiplied by 3. It'll be negative 3, but the absolute value of that is 3, times the negative gets you that. So now you have a graph that's going to be reflected across the x-axis, so it's going down, and it's going down at a rate 3 times greater than it was before. So that 3 inside or outside in this particular one doesn't really affect what happens. It's going to change the slope in the same way, whether it's inside or outside the function itself. All right, so you're going to have that to work with. All right, I think hopefully you guys are starting to remember some of this stuff. I'm going to go to a new page just because I want to start with a clean graph again. So let's insert another graph, and let's do that. All right, so now going over here, let's do another one. Let's do y equals, I'll stay in purple, I guess. Let's do y equals 2 times the absolute value of x plus 1. So what happens now? That 2 in front is going to make it go narrower, right? The x inside stays as it is. The plus 1, now what happens? So we've changed the width of it. It's going to be narrower, but that plus 1, when it's outside the function, you're adding 1. When you add or subtract outside the function, it's going to go up or down. In this case, it's positive, so it's going up. So now, think of what happens if we plug in a value. If I go back to my table of values and I plug in 0, 0 in here becomes 0, times 2 is still 0, plus 1, so now I get 1 here. So I'm starting here now. So everything's been shifted up 1, translated up 1, and it's going to have the slope of 2. On the other side of this, it's going to go back 1, up 2, and we would have this graph. And this side as well. Let's see, did I get there? Looks like I got it reasonably close there. All right, so we have that, right? So that outside the function, that plus or minus, is going to move it up or down. Now, do you remember what moves it side to side? Inside the function, adding or subtracting. So let's look at one of those. So let's look at, let's draw it this color. Y equals absolute value of x plus 2. So now we've got an added 2 inside the function. Right? So inside the function, what happens? Does anyone remember this? If you said it goes the opposite direction you think it should go, you were right. So instead of moving up or down, we now are talking left or right, and a positive moves it left, a negative moves it right. And let's see why that works. Let's put our values in again. If we do x and y, and I put in x equals 0, what happens? X is 0 plus 2 is 2. Absolute value of 2 is 2. So at 0, we're at 2. And you may say, well, that looks like we moved up. But look what happens when, let's see. I want to move that down just a little bit. All right. So this came out to be 2. But look what happens when I put negative 2 in here. At negative 2, what do we get? Negative 2 plus 2 is 0. Absolute value of 0 is 0. So we're here. And now let's try something. Let's go to negative 4. Negative 4 plus 2 is negative 2. The absolute value of negative 2 is 2. Do you see the V shape that's starting to happen here? We've got our V. So we're always going to have a V when you have that absolute value. It's always going to be that V shape. So you never have to worry. It's always going to be that. All right. So we're going to be doing this. Over 2 and up 2 each time. Let me do this right through there. And then, well, I dropped it a little bit at the end there. Sorry. And then through there. All right. So this would be our graph of that function. Moved it left 2. All right. So in general, what I want you to think of is this, and we'll come back to this because I use it a lot with different functions. But in general, if you have a function, if you say y equals plus or minus some value of a is just a constant, times some function, and let's do it this way. Let's do it as, okay, I got to go back here, sorry, just a moment. Let's do it as f of x plus or minus b, and then we'll say plus or minus c. What we know is this, if it's positive, we're looking at it in its normal configuration. All right, it stays, in this case, it would stay this way, right? If it's negative, it turns it downward. And that's going to be generally the rule. It's going to, the negative reflects it across the x-axis. So wherever it was, it's going to reflect across the x-axis. All right, when we have a negative. Positive, it just is what it is. What does the a value do? Well, this a value is going to increase or decrease that slope. So if it is a number that is, let's say if a is greater than 0, then it's going to narrow the function, or it's going to increase the slope of what we have, right? It's going to increase that rate of change. if a is less than 0, and I'm using some words, we're going to change these words later in this semester. Right now I'm just trying to keep it simple with the general behavior, and we can just talk about it in some basic words. All right, so a less than 0, it is going to widen that one. Let's talk about it that way. It's going to widen that graph, where here it was narrowing it, I should say. Okay. And all right. So that's in general what's happening there. Now, let me do one thing here. All right, so as I was saying, we're just going to talk about it in general terms. It narrows that absolute value function or widens it. Okay. Now let's look up here. That b value. Whoa, I lost my marker there for a second. All right, let's do that. All right. So what does that b value do? Well, if it's positive inside the function, now this is inside the function, adding a number, it's going to move it left. It's going to translate it left or shift it left. If it's a minus, it's going to move it right. Last, the c value, that is an addition outside the function. This is outside the function. Now adding is going to move it up, translate it up. A minus is going to move it down or translate it down. It's going to shift it down. All right, so that's in general what we see with functions. When we have something multiplying outside, it's going to change how fast that thing grows, or slow the growth, or increase the growth, or the decrease. All right, so that's our general idea. So let's do one more problem with this, and then we're going to move to a new function. So now, let's insert that graph again. And there we go. All right, so now let's do a crazy one. Let's do y equals to absolute value of x minus 1. Whoops, that's supposed to be an absolute value. I'm going to erase that. We have time. All right, so we're going to do that. X minus 1, absolute value of that, let's say plus 3. So what I know is this is going to have a slope of, on the positive side, it's going to have a positive 2 slope. On the negative side, it's going to have a negative 2 slope. X minus 1, that means everything's going to shift left 1, or I'm sorry, right 1, and then plus 3, up 3. So I'm going to go right from where I know this graph normally starts at 0, 0. And because of that minus 1, I'm going to move right 1. Because of the plus 3, I'm going to move up 3. This is the new center of my graph. What do I know about the new slope? It's going to increase by 2 for every 1 I move over. So if I go over 1, I would go up 2. If I go back 1, I go up 2. And then I can draw the rest of my graph. And we're going to come back to this, and we're going to use some more mathematically precise language to describe it later in the semester, but not now. Right now, I just want you to get used to the behavior and be able to draw these graphs more than anything, rather than use the words. All right, so that's what our graph would look like. Now, let's look at a new function. All right, this one is one that isn't too bad if you understand where it begins. And I'm not going to use a graph, one of my inserted graphs for this, because this is one that I like to draw freehand, because I like to look at really close to where it's at. All right, so first let's look at the behavior of what it does. You knew what absolute value does. Let's do this. Y equals, and I'm going to draw this thing. Now I'm going to tell you that this could be a double barred. These are the same thing. Whoa, I did not want to do that. All right, sorry about that. All right, so that is the same thing as this. A double barred bracket or a bracket. You can also see it with just the bottom. They call it floor function, just the bottom bracket, not a top bracket. What you're going to see in most of our stuff, in the book they'll usually use this, but in most of the quizzes and tests they use this. All right, this idea here, just the bracket. So what does it mean when we say this? What this thing means is y equals, if I will write this in words, which I'm doing right now, if it'll let me. Let's see. All right, there we go. All right, y equals, and I wanted to put quotes up here, but it doesn't want to let me. the greatest integer not greater than x. All right, that's what this means. Y equals the greatest integer not greater than x. That's when we have that bracket or a double barred bracket. That's what it's going to mean. So what does that mean numerically? Well, I like to think of it as a number line. All right, if I have a number line and we draw ourselves a really poor number line here, starting to get a little lag, so I'm going to slow down for a second here. All right, so we have that, and all right. Okay. Alright folks, sorry about that. I was having a little trouble with lag. I just went back out. So if I draw a number line, so let's see, let's do this. And we look at this number line and I ask you, what is this value? And let's look at that. So if we read that, and I just want to clean up some of this mess that happened from when that was going on. All right, so if we have y equals the greatest integer not greater than 3.1. All right, we know 3.1 is right somewhere over here. Let's get another color so we can see it better. 3.1 is somewhere around here, right? It's past 3. What is the greatest integer not greater than? It's the first integer to the left on the number line. So y equal to the greatest integer not greater than 3.1 means it's equal to 3. All right, in the same way, if I do some others, let's do, let me get a little bit of space here. All right, so if we do some other numbers, let's do, let's say y equals greatest integer not greater than 2.8. What do you think that is? Again, look at the number line. We know greatest integer not greater than is going to be to the left. So y equals greatest integer not greater than 2.8 would be 2. All right. What about y equals greatest integer not greater than 1? Well, what is the greatest integer not greater than 1? Again, let's talk about integers. And remember, integers, I guess I should have started there. Integers are those numbers on the number lines, right? It's not the spaces. Remember, we went through all that thing about the different number sets. The integers are these things on the number line. All the natural numbers, 0, and all the opposites of the natural numbers. Remember this? All right. So y equals 1, or greatest integer not greater than 1, is 1. Because 1 is not greater than 1. Right? It's not saying less than it. It's just saying it's not greater than it. So y equals the greatest integer, or 1 equals the greatest integer not greater than 1. All right. So let's do some others. If we continue, same vein, let's do y equals greatest integer not greater than negative 1.2. So now, think again. What did we say about? Look at where it would be on the number line. In which direction on the number line do we go? Right, we go to the left. So if we're going to the left from negative 1.2, or negative 1.2 is somewhere around here, we're going left. Greatest integer not greater than it would be negative 2, because negative 2 is not greater than negative 1.2. If you thought it was negative 1, remember, negative 1 is a greater integer than negative 1.2. It's to the right of it on the number line. All right, so you get the idea of what this looks like, or what this operation does, this greatest integer operation. That's what I want you to understand first. All right, now let's see how we're going to use it. How we're going to use it is pretty straightforward. We are going to draw the graph of y equals greatest integer x and other variations of that graph. All right, so what does y equals greatest integer x look like? I'm just going to make a grid and put a few numbers on this. Always label your graphs nicely, at least on the x and the y axes. And so we got this, and we have this, and we'll start here. All right, So now let's start thinking about if we just generate from x's y's. So if I start out, for example, at x equals 0. All right, at x equals 0, if I put it in, y equals, if I do this, and I do our x's and y's, and I put 0 in for x, y is the greatest integer not greater than 0. That's 0. So at 0, 0, we have a point. All right, now think about it. Everything else I put in here, if I put in going to the right, 0.1, 0.2, 0.3, and so on, what's going to happen? Greatest integer not greater than 0.1 is 0. From 0.2 is 0. 0.3 is 0. So this is going to continue as it goes along, right along this line, right? And it's going to keep doing that all the way until we hit, I mean, you can go to 0.999 and you're still going to get greatest integer not greater than 0.9999 on forever is still going to be 0. But the minute we put 1 in here, what happens? Greatest integer not greater than 1 is 1. So it would jump. All right, this graph has a jump. It's going to go across like this. But when it hits 1, it's not at 1. Remember how we show that? We show that with an open circle. It gets infinitely close to 1 but doesn't hit it. Hopefully you remember that from graphing linear equations last year, or 2 years ago I think would be more often. And then what happened at 1? At 1 it jumped to 1. So it went to here. All right, now, from 1 what happens? Well, everything, when I go across at 1.1, 1.2, 1.3, if I put all those in, what do they give me? They give me 1. So this is going to continue across at 1 until it hits 2. All the way infinitely close. And then it hits 2. What happens? It jumps to 2. And then what happens? 2.1, 2.2, 2.3. All those greatest integers not greater than those values is 2 until we get to 3. And then it jumps. And it's going to keep doing that. All right. Now, if you look at this, what does it look like? Kind of staircase? This is often referred to as a step function. Okay? Now, what about going backwards? Let's do it this way. If I had, let's start another one for the negative side. If I had negative 0.1, as soon as I got to the left of 0, what's the greatest integer not greater than? It's going to be negative 1, isn't it? So right when this goes over here, it drops to negative 1. Right? Not at 0. But right next to it, and then all the way across until it hits negative 1. At negative 1, it's going to be negative 1. So now look what's happening. This is just continuing the pattern, isn't it? And that's why I say with this function, as soon as you find out how wide the step is, this length, and how tall the step is, and where the first step is, you kind of can just continue the pattern. Okay? Because this is just going to keep going back, down by 1, across by 1. It's going to have the closed circle on the left side, open circle on the right, all the way through this. All right? Now, I know this is new, but it follows nice patterns. Let's do another one. If we do another one, let me change my color first. Let's get another color. Let's do y equals 2 times greatest integer x. Well, what happened before? When we did 2 times absolute value of x, it got steeper, right? It went narrower on the v. Well, let's see what happens here. I kind of want you to guess. If it got narrower as the greatest integer, what do you think might happen? When we do this in class, I usually have people try to draw it first. So try to visualize what that would look like, and then let's start to draw it. All right, if we draw this thing, and I do the same thing, I always like to just draw my graph because I don't want a little graph. I want one with a lot of space between it so I can see what's happening. And we'll go this way a little bit and that way a little bit and so on. All right, so we got this. So what's going on here? Well, at 0, what happens? 0 gives me 2 times 0, gives me 0. So it would appear, and I'm going to go back to red to graph this. It would appear we stay at 0, 0 here. So it's starting there. Now what? 0.1 still gives me 0 in here. 0.2, 0.3, all these give me 0 multiplied by 2 is still 0. So it looks like this is going to do the same thing all the way across here until we hit 1, because at 1, what happens? Greatest integer not greater than 1 is 1 times 2 is 2. I know everything I need to know about this graph right now. And why do I say that? Because I know it is 1 wide and 2 tall. I can just continue that pattern. 1 wide, and if I wanted to continue this up, it would go 2 tall, and that was supposed to be open there. Make sure you over-exaggerate those open circles. All right, and then what happens going backwards? Well, it's going to go down 2, and it's going to have the open circle on the right, and it's going to go over 1. You're going to continue that pattern. Once you know how wide and how tall it is, you can just continue the pattern. I actually think these are really nice and easy once you get used to it. Let's do another one real quick. Let's do, let's see. I need to change my color again. All right, so let's do y equals greatest integer not greater than x plus 1. All right, what does it normally do if we had x plus 1 in there? It would move everything left 1, right? So let's see if that works out. All right, 1, 2, 3. Always label your axes. Just a word to the wise. That's how you get full credit. All right, so let's start. Let's start at 0 again. If I put 0 in here, I get 1. Greatest integer not greater than 1 is 1. All right, so I'm up here. I'm starting out. Let's get some color again. Let's do something different. All right, so we're going to start here. Now, what happens? Well, if I put in 0.1, I'd get 1.1, which is 1 when you take the greatest integer. 0.2, 0.3 would be 1.2, 1.3, which then greatest integer is still 1 every time. So that's going to go across to here until we hit 1. When we hit 1, what happens? We get 1 plus 1 is 2, and we start here. So I have everything I need right now. All right? Everything I need. Don't overthink these. It's 1 wide, 1 tall, closed circle on the left, open circle on the right. So now I just continue that pattern. I can go backwards the same way. And if you say, well, that didn't do what we thought it was going to do. We thought it would move left 1. It moved up 1, but it didn't. All right, it looks like it moved up 1 to you, but think about it. This part that was right here before slid left 1. So did the one that was right above it. It slid left 1. It looks the same as absolute or the greatest integer of x with plus 1 on the outside, but it is a different function. So you have to be careful. All right? Do you understand what I'm saying? That one that was right here, remember our original function would have had, if it was just greatest integer x, it would have been a closed circle here and then going across open circle here. So this thing just moved left. It went this way, 1. So everything we thought happened, happens. This function will operate the same way all your other functions operate. That same pattern I showed you works for this greatest integer function pattern. That's what we're going to be working with today, guys. I'm going to leave the rest of you to kind of play with in your homework. And rest assured, do your best with these, please. Every year, I have people quit on these. I didn't know what to do. Yes, you do. You can always go back to a table of values. You hear me say this again and again. What did I do every time? I just plugged in numbers. Plug in numbers in between the integers, all those kind of things. See what the pattern is. Find out how wide that step is. Find out how tall it is. Try to draw something. Don't just give up. Draw something, because then tomorrow when you ask about it, I'll be able to show you how close you were, or maybe how far you were, but it's still, you'll learn. The only way you can learn is by taking your swings like I've talked about before. You've got to give it a shot. Once you give it a shot, your brain's engaged. When we go over it again, your brain locks that into long-term memory, all right? It's going to work a lot better for you. You're going to learn a lot faster. You're not going to have to do as much cramming and studying and all that other stuff. You're going to be able to learn this stuff by approaching it the right way. Again, that authentic type of practice I talk about. All right? So I will see you tomorrow for the rest of this chapter. And we are good to go.